Hey everybody. So today we're going to be diving into one of the simple yet most classic sorting algorithms there is, and that is selection sort. So whether you're kind of a beginner in terms of coding or you're kind of just brushing up on your fundamentals, understanding how this algorithm works will give you a solid foundation in the way we think when we're writing algorithms. So let's kind of break this down visually. I don't have, since I'm just recording the screen, I don't have playing cards with me, but imagine you're sorting like a pile of playing cards on the table. So you go through the whole pile, and then you find the smallest card, and you place it at the beginning of the stack. Then you do it again with the rest. So you find the next card, and the next card that's smaller, and the next card that's smaller, until you get that the whole pile is sorted. So that's basically how selection sort works, and it's pretty easy to understand. So in terms of this array right here, let me fix my layout. Here we go. In terms of this array right here, so we have an array of integers, very small size, and you'll come to understand that selection sort is a good algorithm. Well, not good, but it's decent enough for smaller data structures like this one I have on hand. So the way it works is we'll start at the beginning of our first iteration. We start with 7, and since 7 is the beginning of the iteration, we instantly know, well, first of all, we have two variables that we're gonna be our priority. It's a min and it's a temp. So once we start at the very beginning of the array, we start with 7, and since we know we're at the beginning, there's nothing to compare 7 with. So instantly we set our minimum to 7. And then the way the algorithm works is we go to the next number or integer, in this case, in this array. It's going to compare the two. 1 is smaller than 7. So what we're going to do is change out the min to be equal to 1. And then after that, we're going to go through again. Check. 3 is smaller than 1. No. Next, check. 2 is smaller than 1. No. And then go through the rest of the array until we find anything that's smaller. Or if nothing's smaller, then we know at the end of this first iteration that 1 was the smallest. So now, like I said, we started with this index, which is 0, 1, 2, dot, dot, dot. And these indexes match up. So the array at index 2 is equal to 3. And then vice versa for the rest of them. So starting at index 0, we have this value of 7, and we already iterated through this list, and we found that the minimum was equal to 1. So the way that selection sort works is we just swap these two. So the first thing we do is we set 7 equal to the temp, because we want to store this value in our temp, in a temp variable. That way we don't lose a value when we're swapping it. And this is the actual swapping process. So we're going to switch 1 and 7. So now that we know that 1 was the min here, we're going to erase 7 since we safely have 7 stored here in the temp. We're going to set 1 here, and this is what the array looks like during the swapping. So now we have 1, 1, but now we go back to the indices of where 1 was placed. So this was the index for 1, and we're going to swap that with 7. And we'll set 7 here, just like that. And then since it is a double loop, we're starting our next beginning iteration is going to start here. So then we can erase temp and erase min. Starting again at the beginning, since we're starting at this point, 7 is going to be our min since there's nothing to compare with. And then we check. 3 is smaller than 7? Yes. So our next min is going to be 3. And then we check again the next one. 2 is smaller than 3? Yes. So 2 is going to be set to our minimum value. And then we go forward and then forward and then forward. Nothing was smaller. So now we know that 2 is going to be the next swap. So here we have this index, which matters, and this is our current index. So now we do the swapping again. We set temp equal to this 7 because we don't want to lose this value, and then we do the swapping. So then we place 2 here, and then we update the previous where we swapped with that 7. And that's it. That's pretty much the gist of it. But in terms of the code, I'll walk you through the code in an IDE I have right now with this same exact example, if I still have it written correctly. Let's jump over there. Okay, so now let's look into the code. So here I have just an array of integers like the ones we had on the previous screen. So first things first, what I want to do is print out the array. beforehand, and then we'll print out the array afterhand. So let's do a print before sorting is what we want to see what it looks like before. And then we're gonna do a after sorting. Okay, so let's iterate through this for int I and array. We want to do a sysout print. We're going to do I plus space. And then we're going to sysout the end bracket or end curly brace. So close that up, and then we'll add a new line here. Clean that off, and then let's copy paste this for after the sorting. Okay, let's close this up, All right, so in between, before and after the sorting, we're gonna call this method that we created. Let's just clean this up, selection sort, and then we're gonna pass that input array that we created as the parameter. So now going into the actual selection sort, what we wanna do, like I said previously, is gonna be a double loop. So first things first is we're gonna iterate through I equals 0, I is less than the array dot length. This is going to be your basic iteration, I plus plus. And now that we have here, now we're going to iterate through the inside. So I mean, this is iterating through already, but we're going to do a double loop to go one by one for each iteration. And the trick here is that j is not going to be set to 0 like how you'll see in a general for loop, but j is going to be set to I minus 1. That's because, or I plus 1, sorry. That's because by this point, when we're here, whatever's already sorted before I is whatever's before I in the first iteration is already going to be sorted. So we don't need to check those each time. So now we're going to go through j minus array dot length, and this is not going to be length minus 1 because we're already incrementing. Let me put that here first before I explain. This is not going to be minus 1 because we're already incrementing j each time. So once we get to the back of the second iteration each time, once we get to the back, then we'll get an index out of bounds, or we would not check that last number because we're already incrementing here. So this looks good. And then I think before here we want to store a temp, or the min actually. The min is going to be I each time. So now that we're inside, and this means like I said, so whatever we're at the start of the iteration, that's going to be set to the min because we're not going to be checking it every time. So what we're going to do now is we're going to do, if this is going to be the actual check to see which element is smaller. So array, now we're checking if the array at our current j is going to be less than the array at min. If it is less than, what we're going to do is update this min value to be equal to this j that we're looking at, because we want to go through until ideally at the end of the iteration. Once we're like here, for example, then we'll know for this first iteration, for example, once we're right here, we'll know that I is nothing smaller than I at this point. So the array at j for this first iteration would be at 9, and array at min would be at 1 once we're at the back. So we'll set that though. So min is going to be equal to j, meaning we found the smallest object, or integer in this case, during that loop. Okay, so now on the outside, now we're outside of the inner loop. So we're done with that checking to find the minimum value. What we need to do here is perform the actual swapping of the elements inside of the array. So first things first is we want to store that temp so we don't lose it. And that's going to be stored to what is currently the min. And now we're going to swap the two. So array at min is going to be equal to the array at I. And then we want to put that temp value, this temp value, back into the array so we don't lose it. Array at I is going to be equal to temp. Okay, and this is, remind you, this is also inside of this loop. So at the end of the inner loop, we're going to do this swapping, and then we're going to go back to the outside and then do the same thing again. So it will repeat again and again and again until we're done going through the entire array twice. That makes sense. So this, I think this is it. So this should work if we run it min I. Let me double check. Minimum I minus 1, I plus plus, j equals I plus 1, j plus plus if j is less than the min set to j. Yeah, I think this looks good. Let's double check everything up here for the printing. Looks good. Okay, let's run this once and see what we get. Should clear. Let's run this. Okay, so we get 7. This was the previous, and it looks like it worked already on the after 1, 2, 3, 4, 5, 7, 9. Yeah, looks like it worked. So let's just throw in some dummy values in here just to double check that the actual sorting is fine. So let's put like, I don't know, 3, 7, 5, 2, 1, 55. We can put any number in here, 100, and then we'll do 9999. Let's swap these so that way 99 can be at the back. 100. And let's see how this one looks. Okay, it looks like it's working still. So 1, 2, 3, 5, 7, 5, 5, 100, and then 9,000. Yep, everything looks good. So that kind of wraps up our deep dive into selection sort. Like I said, it's a simple and great way to understand the basics of the sorting algorithms, even though it's not the most efficient for large data sets. Matter of fact, let's put that here. So worst case scenario is going to be O of n squared. Where's my, there it is. And then the best case scenario is also going to be O of n squared. And that's because no matter what the size is of the input, we're always going to loop through once and we're always going to loop through twice. So it's always going to be best and worst case n squared. So even though like I said, it's not the most efficient, but it lays the groundwork for more advanced concepts as you'll run into in the future once you start developing more. And yeah, thanks for watching.